Sleepers, also known as ties, are one of the most recognizable railway components. They sit across the railway at regular intervals, supporting the rails. In this video, we will look at the functions of a sleeper and the materials from which they are made. Sleepers have 5 fundamental functions. 1. Distribute the load of the train over a wider area and down into the ballast below. This reduces stress on the underlying ballast and formation. 2. They hold the two rails the correct distance apart, or gauge. 3. Due to their shape, weight and resistance of the ballast, they resist longitudinal movement. 4. Similarly, they also prevent lateral movement that might be caused by trains moving around curves or by thermal forces of the rails expanding. Lastly, 5. The sleepers electrically insulate the two rails. This is important for both signaling and traction systems. Sleepers are typically made from 3 different materials: wood, concrete, and steel. Each has its advantages and disadvantages. Wood or timber sleepers are easy to handle and versatile, given that they can be re-drilled easily. This means that they can be pulled through and re-drilled to fit a new base plate if required. However, their relatively light weight gives less mass to the track, a disadvantage in times of hot weather. Holes drilled for base plates are susceptible to elongation, leading to gauge issues. Even when treated, they deteriorate faster than sleepers of other materials. Steel sleepers are also relatively light, given that they are stamped out of sheet steel. They also have good resistance to lateral and longitudinal movement. As they are metal, they also last a lot longer than wood. They also don't have the tendency to crack like concrete. But their hollow design makes them hard to lift and pack to repair top faults, while their spade ends prevent slewing. Also, being metal, they are harder to insulate from electrical currents, which can cause signaling problems. Finally, concrete. The most common in the UK. Its weight and dimensions lead to a secure track construction that can resist thermal and other forces. They have a long life and provide good, consistent maintenance of the gauge. While their weight is an asset, it does make manual maintenance tasks, such as changing them, challenging. A new material that is being used more and more for sleepers these days is plastic. Its largest positive attribute is its lower environmental impact than either wood or concrete. Suitable hardwood for sleepers has to be harvested and shipped from where the trees are found that are of the correct age and quality. Concrete production uses a large amount of energy and water while also releasing a lot of CO2. Given its relatively new introduction, its long-term performance and pros and cons are still to be seen. That is an introduction to the functions of a sleeper and the different types.